Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P100C, which indicates an electric VTC motor speed signal circuit malfunction in the Honda Civic 2022 and onward models. The variable timing control VTC system plays a crucial role in optimizing engine performance by adjusting the timing of the intake valves. This system relies on various sensors and the powertrain control module, PCM, to function correctly. When the electric VTC motor speed signal is inconsistent between the EVTS, the speed sensor, and EVTD, the timing reference signal, the PCM registers this discrepancy, indicating a potential malfunction. This guide will walk you through the detailed steps needed to diagnose and fix this issue. The DTC P100C refers to an electric VTC motor speed signal circuit malfunction, primarily affecting the performance of the variable timing control system. This system utilizes the electric VTC motor, which is responsible for adjusting the timing of the intake valves, thereby enhancing engine efficiency. The electric VTC motor is typically located near the engine assembly and connected directly to the powertrain control module, or PCM. When the EVTS and EVTD signals do not align over a specified time frame, the PCM detects an error, which leads to the storage of this diagnostic trouble code. Proper functioning of this system is essential for optimal engine performance and fuel efficiency. There are several possible causes for DTC P100C. First is the potential for open circuits in either the EVTS or EVTD signals, which would interrupt the communication necessary for the VTC system to function correctly. Grounding issues may also arise, leading to signal inconsistencies. A faulty electric VTC motor itself could be the root of the problem, particularly if its internal components have failed. Lastly, a malfunction in the PCM could cause it to misread the signals from the VTC system, falsely triggering the DTC. Each of these components should be inspected thoroughly to determine the precise cause of the issue. When DTC P100C is triggered, several symptoms may manifest. Drivers may experience engine performance issues, characterized by stalling, reduced power, or erratic engine behavior. Additionally, fuel efficiency may decline as the VTC system fails to optimize engine timing correctly. An activation of the check engine light, CEL, serves as an initial indicator that something is wrong within the vehicle's engine system. Each of these symptoms suggests that the vehicle requires immediate attention to restore its optimal operational capability. The first step in troubleshooting DTC P100C involves turning the vehicle to the on mode, which allows the engine and electrical systems to power up without starting the engine. Next, the Honda Diagnostic System, HDS, should be employed to perform an in-VTC test. This test checks the VTC system's operational parameters and determines if the electric VTC motor is functioning correctly. If the test results are not satisfactory, the next steps in the diagnostic process must be completed to identify and address the malfunction. The second step in troubleshooting DTC P100C focuses on inspecting the EVTS and EVTD circuits for any signs of open circuits. This inspection is crucial, as open circuits can disrupt signal transmission between the electric VTC motor and the PCM, leading to the error code activation. The circuit inspection should include verifying that the resistance between the terminals is less than 1 ohm when the EVTS and EVTD are in the off state. If these conditions are not met, further investigation into the wiring or connectors may be necessary. Step 3 involves ensuring that the EVTS and EVTD circuits are properly grounded. If grounding issues exist, they can lead to inaccurate signal readings and trigger the DTC P100C. Using a multimeter, check for any shorts to ground by verifying that the resistance is greater than 1 megaohm when the circuits are in the off state. A reading lower than this indicates a problem, necessitating repairs to the affected circuit. Ensuring proper grounding is critical for the overall functionality of the VTC system. The fourth troubleshooting step focuses on the inspection of the electric VTC motor itself. After completing prior checks that have indicated normal conditions, disconnect the electric VTC motor 6P connector and inspect for any damage, corrosion, or loose connections that may hinder its operation. Also, verify the internal components of the electric VTC motor for functionality. If anomalies are detected, it confirms a problem with the electric VTC motor, requiring either repair or replacement. This component must be in proper working order for the VTC system to function optimally. After making necessary repairs based on the previous steps, it is time to verify the effectiveness of the repair. Start by clearing the DTC codes using the HDS, ensuring the system resets and clears any stored issues. Following this, conduct a road test to confirm that the vehicle operates normally without triggering the DTC P100C again. During the road test, monitor engine performance to ensure there are no recurring symptoms associated with the initial problem. Successful conclusion of this step means not only confirming the repair, but also restoring the vehicle's optimal performance. Preventive maintenance can significantly reduce the chances of encountering DTC P100C in the future. Regular inspections of the VTC system will help catch any early signs of failure before they lead to larger issues. This includes checking electrical connections for any signs of wear, corrosion, or damage regularly. Keep the wiring associated with the electric VTC motor and the PCM in good condition, as environmental factors can contribute to corrosion over time. Additionally, periodic software updates to the PCM can provide enhancements that ensure the VTC system continues to operate correctly and efficiently. In conclusion, diagnosing and resolving DTC P100C involves a systematic approach to understanding the electric VTC motor speed signal circuit malfunction. Recognizing the role of critical components like the electric VTC motor and the PCM is essential for proper diagnostics. Following the outlined troubleshooting steps is crucial to identify the root cause effectively, whether it's a simple wiring issue or the need for component replacement. Regular maintenance and monitoring ensure that the system functions optimally, preventing future occurrences of this issue. Always stay attentive to engine performance and be proactive in catching potential problems early. Please like and subscribe to the channel. See you next time.